Welcome to another video to assist you on dealing with this database questions in GCE Local ICT A levels, right? Well, most of you have seen, like by now, you know that there are so many questions from database, just like programming Python. So this is one video of so many videos to come in the future, in the near future, and let's get into the business. This is actually from 2011 A-level ICT MCQ paper. See the following system description and relations A, B, C, D given below to answer the questions 24, 25, 26, right? A principal of national school wants to develop a database to maintain admission number, student name, address, national identity card number, and the date of birth, the advanced level students. The principal wants to know the marks obtained for each subject by students. In addition to the above requirements, the principal needs to know the subjects assigned to the teachers. So you can see that there are relations of different tables initially designed. Student, admission number, student name, address, DOB, NIC. So you can see all are related to the student. Subject, subject code, subject name, yes, both of them related to this. Mark, admission number, subject code, marks obtained. This admission number for this particular subject, because the student can take many subjects. So admission number 1, subject 1, admission number 1, subject 2, something like that, right? So there also it's dependent on, marks is dependent on both these. And teacher, teacher number, subject code, teacher name, subject name, and class. Right, subject code, teacher name, subject name. Right, so that's some kind of at a glance you see there's some kind of mismatch there, right? Which of the above relations are in the third normal form? Right, so if you look at the normalization steps, right? In the first normalization 1NF, what we do is we look at the repeating values. Now this is where we come across composite primary keys, right? If one set of values are repeating on another, what we do is we break it into two groups, and then the two relations will be linked using a foreign key and a primary key, right? In the second one, second NF, we are looking at partial dependencies. That's fields which are dependent on part of the composite key, primary key. So composite key is a primary key which is made up of multiple fields. So we look at partial dependencies where fields dependent on part of the primary key will be taken out and put them into a new table and linked using primary key and foreign key. In the third normal form, what we look at is we're looking at non-key dependencies. So here of course it was the fields dependent on part of the primary key, but here it's the fields which are dependent on non-key attributes. Okay, so better you go back to the normalization notes and study it. You can also check online resources. Right, now if you look at the first one, of course it's in third normal form, no issue in that. B, that's fine. C is fine, but if you look at D, you can see teacher number, subject code. So this is supposed to store details of teacher, such as teacher number, teacher name, and the class, but subject name is dependent on the subject code. Now subject code is not part of the primary key here. Primary key here should be the teacher number, right? So this is not in normal form, because third normal form we remove any fields that are dependent on non-key attributes. For example, the subject name is dependent on subject code, so we take this out and store it as a separate relation or table, and then link to this table using the primary key and the foreign key. So that's how we do it. So subject code will be a foreign key here, and there will be another table called subjects. Oh, it's here. You can see the subject name is repeating here, so we can anyway, this can be related to this, linked to this subject, so we don't need subject name here. So that is non-key dependency. Teacher name is fine, it's dependent on teacher number, and the class is also dependent on the teacher number, right? Okay, so the answer is A, B, C. Which of the following combinations of attributes provides a minimum set of primary keys for the relations student, subject and mark respectively? Which of the following combination of attributes provide the minimum keys for the relations student, subject and mark respectively? So these combinations of facts are called super keys. From super keys only we get the candidate keys. Candidate key is the most the least number of fields that we can use for the primary key, but super keys are the combinations of these primary keys, right? Okay, so if you take the student respectively, student, it is the admission number. It is the admission number. If you take subject, it is the subject code. If you take the mark, of course you can't take the admission number alone, because one student may do many subjects, so we need to use admission number and the subject code both as a composite key, right? So the answer would be admission number, subject code, admission number and subject code together. So it's this one, the fourth one. Which of the following SQL statements would produce the output with admission number, name of the student, subject code and marks obtained? Right, so we are selecting, it's a select command. So what are we going to select? We are going to select the admission number, name of the student, subject code and marks obtained. The first one doesn't have the admission number. Second one, admission number, student name, subject code, marks there. Okay, so we can leave out the wrong ones. This one has admission number, student name, subject code, marks obtained. This one, admission numbers, marks obtained, yes. Yeah, so we can leave out one. And then in order to get marks obtained, you need to link it to the mark table. Okay, how do you link to the mark table? Now what are the fields you need? You need admission number, name of the subject code as well, right? The subject code is there in the mark table. So you need to get the admission number from student, student name from student, and then subject code and marks from the marks table. So you need to link student and mark. So how do you link? Using the primary key and the foreign key. So here you can link admission number to admission number. Student dot admission number equals mark dot admission number. So that's the link you can have. Right, so let's see which one says like that, where student dot admission number equals mark dot admission number. One we have left. student dot admission number, mark dot admission number, right, that's okay. Student dot admission number, mark dot admission number, that's also alright. This one is wrong, so you can see just admission number, it doesn't say where what the table is. This goes and this also goes, so it's 2 or 3, right? Okay, so from student mark, okay, right, so here of course we say student admission number and student marks obtained. Now that one of course student admission number is fine, but student marks obtained is wrong, right? Because marks obtained does not belong to the student table, so this also goes. So the answer is C. So again check, select student dot admission number, student name, subject code, marks obtained from student mark, where student admission number equals mark admission number. Right, so remember, when you are linking the tables in your where clause, this is how you put it. You need to specify the table name dot the primary key and the other table dot the foreign keys. You need to equalize it. So hope it's clear. We'll meet with another quick video about database discussion.